Germans were astonished when proximity fuses wiped out entire formations at the Battle of the Bulge. December 14, 1944. Headquarters, 12th SS Panzer Division, Belgian Ardennes. Obersturmbannführer Heinrich Vogel lifted the intelligence report and sneered at the thin paper. His iron cross glinted in the lamplight as he tossed the document across the table. "Look at this," Vogel said, flicking ash from his cigarette onto the offending papers. "The Americans believe they can stop us with radio-controlled shells. They cannot even coordinate their infantry without confusion." Sturmbannführer Klaus Weber nodded, adjusting his knight's cross. "Their soldiers still use separate frequency radios. They trip over their own supply lines." Hauptsturmführer Otto Kraus, chief intelligence analyst for the division, leaned forward with measured caution. "The technical reports suggest these proximity fuses represent genuine innovation." "Perhaps we should," but Vogel waved him off with contempt. "Innovation? We destroyed 87 Sherman tanks at Mortain with just 18 Panthers. At Arnhem, we annihilated an entire British airborne division. The Americans lost 9,000 men taking the Huichin forest for a few kilometers of trees. Their production means nothing when their soldiers break and run." The mathematics were undeniable. German tactical superiority had been proven in blood across a dozen battlefields. What Vogel didn't know, what none of them could have known as they planned Operation Whacked 'em Rhine in that lamplit headquarters, was that American proximity fuses would destroy over 300 Luftwaffe aircraft within 72 hours. The numbers would become catastrophic, 8-to-1 kill ratios. 14,000 proximity fuses produced daily. Entire bomber formations obliterated in minutes. The confident laughter in that Belgian headquarters would become history's most expensive miscalculation, measured in 47,000 German casualties in the opening week alone. The German High Command had reason for confidence. At Kasserine Pass, inexperienced American forces had suffered over 6,000 casualties against 2,100 German losses. The ratio was nearly 3-to-1. At the Rapido River crossing, the U.S. 36th Infantry Division lost 2,000 men in 2 days trying to cross a single river. American tanks burned by the dozen in the Bocage country of Normandy, where German defenders picked them apart from concealed positions. Every engagement seemed to confirm German tactical mastery. The equipment specifications supported this confidence. The Panther tank's 75 gun could penetrate Sherman armor at 2,000 meters. German MG-42 machine guns fired 1,200 rounds per minute, twice the rate of American weapons. A single German 88 anti-aircraft gun could engage targets at 10,000 meters altitude. These weren't propaganda figures. These were engineering realities that killed American soldiers daily. Recent American failures provided fresh evidence. In November 1944, the U.S. Ninth Army's assault on the Siegfried Line gained just 10 kilometers in 3 weeks while suffering 25,000 casualties. American bombers lost 600 aircraft over Germany in October alone, a 5% loss rate on some missions. Ground attacks into prepared German positions routinely failed with horrific American casualties. Obersturmbannführer Vogel's combat record justified his confidence. He had commanded forces at Prokhorovka, where his battalion destroyed 42 Soviet tanks in one engagement. At Caen, his unit held against 3 British divisions for 6 weeks. He wore the German Cross in gold for destroying 91 enemy armored vehicles. His tactical judgment had been proven across 3 years of combat from the Eastern Front to Normandy. Hauptsturmführer Kraus had presented his concerns based on captured intelligence data, but Vogel dismissed them. The reports mentioned VT fuses and radio proximity detonation, but these seemed like American propaganda. Kraus had shown photographs of shell fragments with miniature radio tubes, but how could such fragile components survive artillery firing? The acceleration forces would shatter any vacuum tube. The mathematics seemed impossible. Unteroffizier Johann Becker, a veteran anti-aircraft gunner, had his own confirmation of German superiority. At Schweinfurt, his battery shot down 23 American bombers in 1 day. The Americans came in rigid formations, maintaining steady courses that made them easy targets. They had numbers, certainly, but numbers meant little against experienced German gunners. Becker had survived 3 years of air defense operations because German training and equipment exceeded American capability. The mathematics seemed irrefutable. Rossford, Ohio, June 1943. Martha Henderson adjusted her safety goggles and positioned another glass tube under the vacuum pump. The Libby Owens Ford facility produced 14,000 miniature radio tubes daily. Every 12 seconds, another completed fuse component rolled off her line. Production progression told the story of American industrial mobilization. In January 1943, America produced just 800 proximity fuses monthly, barely enough to equip 2 artillery battalions. By June 1943, production reached 12,000 monthly, sufficient for division-level operations. By November 1944, the single facility in Rossford was producing 14,000 fuses daily. This single facility was producing more proximity fuses than the entire German electronics industry produced vacuum tubes for all applications. Martha Henderson, previously a schoolteacher from Toledo, now operated precision glassworking equipment producing 200 glass envelopes every 8-hour shift. She produced more miniature tubes in one shift than Germany's entire specialty tube production facility in Dresden manufactured in a week. Her station represented one of 47 identical production lines in the Rossford facility alone. James Washington, from Detroit, operated the automated testing equipment that evaluated each fuse component. His single station's daily output of 12,000 tested components exceeded the entire monthly production of Germany's Telefunken facility in Berlin. The testing process rejected 17% of components. America threw away more proximity fuse parts daily than Germany could manufacture in a month. Robert Morrison, $1-a-year man from General Electric, managed the quality control systems that ensured 92% of completed fuses functioned correctly. Morrison had designed production systems where waste itself became a competitive advantage. American facilities could afford 17% rejection rates because raw production capacity overwhelmed any inefficiency. Americans discarded 400 pounds of copper wire daily from the Rossford facility alone. Germany allocated 32 pounds of copper wire monthly for its entire radar development program. The mathematical disparity wasn't close, it was grotesque. The waste from single-day production at Rossford exceeded Germany's total electronics component manufacturing capacity for specialized military applications. American workers simply threw away defective fuse components that represented strategic materials in Germany. Workers threw away glass tubes with minor imperfections that Germany would have laboriously repaired and reused. A single day's rejected components contained more processed silica than German optical facilities received in a quarter. The cafeteria at the Rossford facility discarded more meat daily than the entire 12th SS Panzer Division received in weekly rations. Workers left uneaten sandwiches containing protein equivalent to a German soldier's 3-day allocation. 500 pounds of aluminum scrap from component housings generated each day at Rossford could have built 17 Messerschmitt Bf-109 fighters using Germany's careful materials allocation. America melted it down and recast it without a second thought. Hauptsturmführer Kraus appeared at division headquarters in early December with new intelligence reports. The Americans have equipped their anti-aircraft battalions with these proximity fuses. Production estimates suggest they're manufacturing over 400,000 monthly. Vogel had laughed. Impossible. That's American propaganda. No one can build that many precision instruments. But Kraus's numbers were conservative. December 17, 1944, near Malmedy, Belgium, 14:23 hours. Unteroffizier Becker was checking his flak 38 guns ammunition when the American fighter-bombers appeared. The P-47 Thunderbolts came in low, 8 aircraft in formation. At 14:24:10, his battery engaged the lead aircraft with conventional shells. At 14:24:47, the first fighter exploded. Elapsed time from engagement to destruction, 37 seconds. But something was wrong. The American aircraft hadn't maneuvered defensively. It had flown straight into a wall of explosions that erupted without direct hits. At 14:25:15, 2 more P-47s disintegrated. Kill time, 18 seconds each. The shells were detonating near the aircraft without contact. Becker saw the flash pattern explosions creating spherical blast zones that caught aircraft in overlapping kill radii. At 14:26:30, the remaining 5 aircraft broke formation and fled. 3 more exploded in the next 45 seconds. Kill times, 12, 15, and 19 seconds respectively. Total engagement duration, 3 minutes 20 seconds. Enemy losses, 6 aircraft, 6 pilots. American losses, 0. Kill ratio, 6-0. The ammunition expended in this 3-minute engagement exceeded the monthly allocation for Becker's entire regiment. Each proximity-fused shell cost 50 times a conventional round, and the Americans fired them as casually as rifle bullets. Obersturmbannführer Vogel received Becker's report at 16:45 hours. He read it twice, then set it aside. Battle stress. The gunners are imagining patterns. Shells don't explode without impact. It's physically impossible. December 18, 1944. Various locations along the German offensive line. Intelligence dismissed the reports as combat confusion. Pilots reported shells exploding in perfectly timed proximity to aircraft, but Vogel's staff attributed this to observer error. German forces had achieved surprise and were advancing rapidly. A few unusual American tactics wouldn't change the momentum. Hauptsturmführer Kraus reported to Army headquarters with urgency. 17 separate incidents confirm proximity detonation. American anti-aircraft effectiveness has increased by 400% in 72 hours. They're achieving kill ratios we've never observed. This isn't luck or observer error, this is systematic technological advantage. The production comparison made Kraus's point clear. American production, 420,000 proximity fuses monthly. German production of equivalent electronics. 0. Germany had no comparable technology. A single American facility at Rossford exceeded Germany's entire electronics production for military applications. The Naval Ordnance Laboratory in Maryland produced more in 1 week than Germany's combined electronics industry manufactured in a month. The Eastman Kodak facility in Rochester, New York, produced more miniature tubes daily than all German specialty manufacturers combined produced monthly. They tried altitude variation. German bombers attacked from different heights to confuse American gunners. The Americans compensated instantly, the proximity fuses detonating at any altitude. They attempted high-speed approaches to minimize exposure time. The Americans simply increased firing rates, creating denser kill zones. They tried night attacks to mask approach vectors. American radar directed proximity-fused fire that destroyed aircraft the German pilots never saw coming. They attempted weather cover operations, flying through cloud layers. The proximity fuses functioned perfectly in rain, snow, and fog. December 19, 1944. Near Bastogne, Belgium, 11:15 hours. Another battle followed the same pattern. 23 Junkers Ju-87 Stuka dive bombers approached American positions near Bastogne. At 11:17:20, American anti-aircraft batteries opened fire. At 11:17:41, the first Stuka exploded. Kill time 21 seconds. At 11:18:03, 3 more disintegrated simultaneously. Kill time 18 seconds each. At 11:18:29, 4 more destroyed. Kill time 15 seconds each. The mathematics were becoming clear. Every shell created a kill radius of 70 feet. Shells didn't need to hit aircraft directly, they just needed to detonate within blast range. American gunners fired 5-round salvos that created overlapping blast spheres. Aircraft caught in these zones simply ceased to exist. At 11:21:40, the surviving Stukas broke off the attack. 14 aircraft destroyed, 9 escaped. Engagement duration, 4 minutes 20 seconds. Kill ratio, 14-0. American casualties, 0. German losses, 14 aircraft, 14 pilots, 112,000 hours of training and experience gone in 4 minutes. Hauptsturmführer Kraus presented his final proof to division command. The Americans aren't just producing these weapons. They've achieved such production capacity that they're using them in ground artillery. Not just anti-aircraft, they're firing proximity fuses in howitzers against ground targets. This level of production suggests they have effectively unlimited supply. Command finally began to understand. The reports from every sector confirmed identical patterns. American anti-aircraft effectiveness had increased 500% since December 16. Aircraft losses were catastrophic. Fighter cover for ground operations had become suicidal. Obersturmbannführer Vogel still refused to believe complete German tactical superiority could be negated by American industrial capacity. We're winning on the ground. Their aircraft losses are irrelevant. We'll push through to Antwerp and force their collapse. Unteroffizier Becker observed the escalation from his anti-aircraft position. On December 16, his battery engaged 8 American aircraft and destroyed 1. On December 17, they engaged 8 and destroyed 6. On December 18, they engaged 12 and destroyed 11. The pattern was clear: American aircraft were dying faster than they could be replaced in theater, but the Americans kept coming. The mathematics said German defenses were winning, but American aircraft kept appearing in undiminished numbers. Baltimore, Maryland, the Western Electric Facility, September 1944. At the Western Electric plant, production engineers achieved 64 proximity fuses completed per hour. Every 56 seconds, another fuse rolled off the assembly line. This single facility produced more proximity fuses than Germany produced artillery shells of all types. Waste appeared in every aspect of production. Americans discarded selenium rectifier components that failed voltage tolerance tests. Each discarded rectifier contained materials Germany allocated only for critical military electronics. The plant threw away more selenium weekly than Germany's entire electronics industry received monthly. Workers threw away miniature capacitors with imperfect dielectric layers. Germany's electronics technicians would have spent hours repairing such components. American workers dropped them in scrap bins without a second glance. Cafeteria waste at Western Electric exceeded German military rations spectacularly. Workers left half-eaten lunches containing more calories than a German frontline soldier received in 2 days. The facility's daily food waste could have fed an entire Wehrmacht regiment. Aluminum scrap from a single day's production, 470 pounds, exceeded Germany's monthly allocation for aircraft electrical systems. The discarded aluminum represented enough material to build 6 Messerschmitt fighters. Discarded ammunition in testing protocols exceeded German combat allocation by grotesque ratios. American facilities fired 1,500 proximity-fused rounds daily just to verify production quality. Germany's entire monthly allocation of comparable electronics for all applications would have fit in 2 wooden crates. Every production metric ended with the same conclusion. This single facility exceeded Germany's entire nation's capacity to manufacture precision electronics. Hauptsturmführer Kraus had assembled complete production statistics by mid-December. American factories were producing 12 million artillery shells monthly equipped with proximity fuses. German artillery production of all shell types combined, 2 million monthly. The single facility advantage had become a national industrial avalanche. December 22, 1944. Operation Bodenplatte Preliminary Actions, Ardennes Sector. 47 Messerschmitt Bf-109 fighters faced 12 American P-47 Thunderbolts. The engagement lasted 14 minutes. At 13:22:00, German fighters engaged at 20,000 feet. At 13:22:43, ground-based American anti-aircraft batteries opened fire with proximity fuses. First German fighter destroyed at 13:23:12. Kill time, 69 seconds from engagement. At 13:24:00, 3 more German fighters destroyed. Kill times, 42, 39, and 47 seconds. At 13:26:30, American fighters engaged with conventional weapons while ground fire continued. 4 German fighters destroyed by 13:27:15. Kill times, 32, 28, 34, and 31 seconds. At 13:29:00, remaining German fighters attempted to disengage. Ground-based proximity fire destroyed 6 more during the retreat. Kill times ranging from 15 to 42 seconds. At 13:36:00, engagement concluded. Enemy aircraft destroyed, 14 Bf-109 fighters. American losses, 1 P-47 damaged, pilot recovered. Kill ratio, 14:0 for aircraft, 14:0 for pilots. The ammunition expended over 2,000 proximity-fused shells exceeded Germany's entire monthly allocation of specialty electronics for radar, radio, and fire control systems combined. The fuel consumed by American aircraft in this engagement exceeded the monthly allocation for an entire Luftwaffe fighter group. At 13:29:17, Obersturmbannführer Heinrich Vogel was shot down leading a formation of FW-190 fighters. Elapsed time from engagement to death, 47 seconds. His aircraft disintegrated when 3 proximity shells detonated simultaneously within the kill radius. The Iron Cross and Knight's Cross he wore represented combat mastery across 3 years. The mathematics that killed him operated at different scale. A captured Luftwaffe pilot provided testimony after the battle. This wasn't combat. This was systematic annihilation. We couldn't maneuver out of the blast pattern. Every second we remained in the air, another shell detonated. We weren't fighting aircraft, we were fighting mathematics. The pattern repeated across every engagement. German aircraft approached American positions. American radar detected them at maximum range. Ground-based anti-aircraft batteries commenced fire. Proximity fuses created overlapping kill zones. German aircraft died in precise mathematical progression. The engagement concluded. American losses, minimal or zero. German losses, catastrophic. January 1945. Prisoner interrogation facility, Luxembourg. Hauptsturmführer Otto Kraus sat across from American intelligence officers. His testimony was precise. We were not defeated by better soldiers, but by better factories. Your single facility at Rossford, Ohio, produced more proximity fuses daily than our entire nation could manufacture vacuum tubes for all purposes in a month. A single American factory produced more in one day than our entire industrial capacity generated monthly. Unteroffizier Johann Becker provided combat perspective. I saw American aircraft absorb direct flak hits and continue flying. Then I saw proximity shells destroy aircraft without visible contact. The Americans had developed weapons that didn't need to hit targets, they just needed to get close. They didn't just outproduce us, they revolutionized what production meant. Additional testimonies from German personnel revealed consistent themes. A Luftwaffe squadron commander stated, "We brought swords to modern warfare. Our tactical excellence meant nothing against weapons that didn't require accuracy. Their excess capacity exceeded our maximum effort." A Wehrmacht artillery observer noted, "They could lose 500 aircraft and replace them in 6 days. We lost 20 aircraft and couldn't replace them in 3 months. The mathematics were absolute." A Panzer Division commander observed, "Their ammunition expenditure in 1 week exceeded our annual allocation. They fired proximity fuses at ground targets, not because they needed to, but because they could." Production statistics stated by captured German intelligence officers confirmed the disparity. American production of proximity fuses, 500,000 monthly by January 1945. German production of comparable electronics. None. Germany never developed proximity fuse technology. Single American facility at Western Electric, 64 units per hour. Entire German electronics industry for all military applications, approximately 3,000 precision electronics components monthly, none comparable to proximity fuse complexity. A German ordnance expert testified, "The Americans achieved something we considered impossible. They mass-produced a miniature radio system rugged enough to survive artillery firing, cheap enough to destroy with every shell, and reliable enough to function 92% of the time. We couldn't manufacture such devices in laboratory conditions. They produced them at 14,000 daily." The testimony from Hauptsturmführer Kraus was most detailed. "I presented reports about American production capacity in November 1944. Command dismissed them as propaganda. I showed photographs of proximity fuse components. Engineers said the vacuum tubes would shatter under acceleration forces. I provided calculations showing how Americans could sustain such production rates. Staff officers said the mathematics were impossible. Every assessment was rejected because the numbers seemed too large. We couldn't imagine production at that scale, so we concluded it didn't exist." The systematic documentation continued. German military intelligence had captured intact proximity fuses in October 1944. Technical analysis confirmed they functioned as reported. The miniature tubes survived firing acceleration through careful mounting and component design. The radio system detected target proximity and detonated the warhead at optimal range. German engineers examined the components and determined Germany lacked the industrial capacity to replicate production. Not because German engineers were less capable, but because German industry couldn't achieve the production scale required. A German electronics engineer testified, "The proximity fuse wasn't a genius invention. It was an engineering solution that required enormous production capacity to implement. The components weren't exotic. The radio tubes were miniaturized versions of standard designs. The real achievement was producing them in quantities that made them disposable. Each shell contained electronics we would carefully maintain and repair. Americans destroyed them by the thousand." The mathematics of industrial warfare had spoken with finality. Germany produced approximately 2 million artillery shells monthly by late 1944. America produced 12 million proximity-fused shells monthly by January 1945. Shells with each containing electronics exceeding the complexity of German radar systems. The single Western Electric facility exceeded Germany's entire artillery production capacity. The Rossford facility exceeded Germany's entire electronics production capacity. American industrial supremacy wasn't slight, it was absolute. December 14, 1944. Obersturmbannführer Vogel had laughed at American innovation. January 15, 1945. Vogel was dead, killed by a proximity fuse he dismissed as impossible. His mockery became history's most catastrophic miscalculation. The proximity fuse proved that democratic industrial organization exceeded authoritarian production systems. Free workers at Rossford and Western Electric and dozens of other facilities produced more, faster, and with higher quality than German facilities using forced labor and rigid command hierarchies. Democratic cooperation exceeded totalitarian command efficiency. Industrial abundance buried ideological claims of superiority under 14,000 proximity fuses produced daily. Martha Henderson, the schoolteacher from Toledo, produced more miniature radio tubes in one 8-hour shift than Germany's entire specialty electronics industry manufactured in a week. Her production represented freedom's industrial manifestation. Workers who chose their employment, who received fair wages, who worked in safe conditions, these workers outproduced slaves and coerced labor by factors of 10 or more. The mathematics weren't close. The lesson proved permanent and absolute. Dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity when motivated by genuine threat invites catastrophic miscalculation. Obersturmbannführer Vogel understood German tactical superiority. He understood combined arms warfare. He understood operational art. What he didn't understand, what he couldn't understand, was that free peoples defending their civilization would outproduce, outbuild, and overwhelm any authoritarian system through sheer industrial capacity. The Battle of the Bulge cost Germany 47,000 casualties in the opening week. Proximity fuses destroyed over 300 Luftwaffe aircraft in 72 hours. German air superiority, carefully rebuilt for the offensive, evaporated under American anti-aircraft fire. The offensive failed not because German soldiers lacked courage or skill, but because German industry couldn't compete with American production scale. The final mathematics were these. Germany produced 2 million artillery shells monthly. America produced 12 million proximity-fused shells monthly, shells that didn't miss, that didn't require direct hits, that turned the sky into a kill zone where aircraft survival became mathematically impossible. 14,000 proximity fuses rolled off American production lines daily. 0 proximity fuses were produced by Germany, ever. The lesson remains, dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity invites catastrophic miscalculation. Industrial abundance defeats tactical excellence. Production scale overwhelms operational art. Free workers outproduce coerced labor. The mathematics are absolute, and they speak with finality that no ideology can overcome.